All right, hello, this is Jeff Scott of Rankin Technical College. I'm going to right now be going over the PowerPoint presentations for the textbook, one of the two textbooks for our class, that textbook being Web Development and Design Foundations with HTML5. I believe we're going to be using the 7th edition, which looks like this. All right, so PowerPoints are going to look along these lines right here. So I'm going to literally just start with Chapter 1. So here are our learning outcomes. Now this is very much an exploratory chapter, and it talks about some things it's probably a good idea for you to know as we get started. You don't have to worry about memorizing anything. All right, just try to soak it all in, so to speak. So when you look on here, what do we want to be able to do? Well, first, describe the evolution of the internet and the World Wide Web. Explain the need for web standards. Describe universal design. Identify benefits of accessible web design. Identify reliable resources of information on the web. Identify ethical use of the web. Describe the purpose of web browsers and web servers. Identify networking protocols. Define URIs and domain names. Describe HTML, XHTML, and HTML5, and describe popular trends in the use of the web. Now, there probably are going to be times in here where I will elaborate on something that's put in the book. There might even be some times in here when I don't totally agree with what the author has put in the book. All right, and you'll notice that as we go on. So, reasons for the internet growth in the 1990s. Well, the idea, if you don't know this, but originally, one of the main reasons, one of the main impetus of the internet was the fact that they, meaning the federal government, wanted to be able to link together different computers, especially military computers all around the world. All right. But as it went on, people really discovered that there was a lot of other things you could do with it, especially, for example, on the educational side, to be able to link different schools together, for example. All right, and they talk about some of the other stuff that's on here. Removal of the ban of commercial activity. Tim Berners-Lee, who kind of started the whole World Wide Web thing in the late 80s, early 90s. Mosaic, which was the first graphics-based web browser. Personal computers were becoming available and affordable, even though at that time, in the 90s, they weren't nearly as powerful as they are right now. Online server providers offered low-cost internet connections. So, here's the author's definition of the World Wide Web. The graphical user interface, which we're always going to be referring to as the GUI, G-U-I. Oh, sorry. So again, I will have to mention, or I should have mentioned previously, I'm taping this in the basement of my home. So occasionally the phone might ring or I might be interrupted by something else, and I apologize for that in advance. But again, the World Wide Web, okay, the www that you put in with a website, the GUI or graphical user interface that's used to house information stored on computers running on web servers connected to the internet. Now, there's a lot more to it than that, as you'd probably guess. There are a lot of different boards out there and a lot of different places that help run the internet as much as it can be run or as much as it can be administered. You can see some of them right here. Now, you'll notice under the IETF, they've got RFC, Request for Comments. Quite often what ends up happening with these governing bodies is what they do is they literally make recommendations. All right, and in an ideal world, at least, all the browser manufacturers, etc., will abide by these recommendations, and then they'll go from a recommendation to actually basically becoming a standard. But when these different organizations put out their recommendations, they put them out typically, like it says right here, with a request for comments. So that gives people who are going to use them the opportunity to comment on them, say whatever it is they want to say about them. I don't think you need to see this. I mean, the growth of the internet, it just keeps expanding all the time. One of the interesting things on here when you look at this, and it's kind of hard to tell taking a look at it right here, but one of the interesting things is it's starting to grow even in what are sometimes considered more underdeveloped countries, all right, such as in regions in Africa. ICANN is one of the more famous internet organizations. You can see it right there. Notice its main function is to coordinate the assignment of internet domain names, IP or Internet Protocol address numbers, protocol parameters, and protocol port numbers. One of the problems that's existed over the last several years is there has been such a proliferation, such an explosion of people having things that need IP address numbers. For instance, I wear an Android watch. My watch has its own IP address. Yeah, my watch can get phone calls. Now, as we start going through this again, I'm going to try to come through and give my own definitions. Intranet, extranet, and then we'll get to the internet in just a minute. But an intranet, at the school that I used to work at, and probably Rankin has it too, I haven't found out yet, but they had an intranet, where basically it was a private network within the institution that could be used to share information among people who work there. But it's an in-house type of thing. Now that's as opposed to an extranet. So with an extranet, let's suppose, for just as an example, let's suppose that I produce and sell nails, that you use to pound, into wood, etc. And let's suppose that I sell these nails to a variety of different companies, such as Lowe's, Home Improvement, Menards, maybe even Walmart, that kind of a thing. All right? So I could have an extranet that would be a private network. So a part of it would be open only between me and Walmart, and another part might be open between me and Lowe's, and another part between me and Menards, etc. And the reason that that's important is, as it says, it only shares part of the organization's information. I'm going to be bound legally and otherwise to not let, for example, Walmart know how much I'm charging for my nails for Menards type of an idea. All right. So when you've got something external, that's when the extranet comes in. All right. Many years ago, when the web began, one of the things that was developed was something that's called the W3C, which stands, as it says there, for the World Wide Web, hence the W3, Consortium, hence the C. Now, just so you see this, if you want to go and do some kind of dull reading, go out to w3c.org. All right, it's not a very pretty website, but it's a very functional website, and it's filled with information on just about anything web that you can think of. This pretty much is the governing body for the World Wide Web. As it says, the W3C develops recommendations and technologies that are web related. They're also responsible for the WAI, the Web Accessibility Initiative. If you want to know more about what all that stuff is about, of course you can go out to the W3C, but you also might want to even do a Google search on ADA, the Americans for Disabilities Act, which was, I don't even know when that was, in the 90s or whenever. But the point is, the idea is that anyone who has a computer has a right to use the internet. And it's the responsibility of people, especially people who work on public sites or people who work on government sites, etc., to make the internet accessible to anyone and everyone. And that's what a lot of this is about. In addition, as it says, I mentioned this before, they make these recommendations. They are trying to standardize web technology. So here's some sites that you can go look up if you want more on accessibility. I will tell you that accessibility is an unbelievably important topic when it comes to websites. And the more you have to deal with government, be it local, national, or international, the more you're going to be bound by making your website accessible to anyone and everyone. There's the ADA that I mentioned before. All right. There is a whole kind of new thing that's sprouted up in the last few years regarding this idea of universal design. And as it says there, the design of products and environments to be usable by all people to the greatest extent possible without the need for adaptation or specialized design. Well, that's all fine and dandy. But you may even, if you go out and you look enough on the web, I'm going to go out to wikipedia.org, which is a really good site. And I'm going to type in UX here. All right. It says UX commonly refers to the user experience, a person's behaviors, attitudes, and emotions about using something. But where this user experience has been really becoming important is, it's a whole big focus now, or a whole big part of working with websites. All right, there are people out there that today are known as UX designers, and the idea behind their idea is basically to make anyone who's going to use the web, to make their web experience as nice as possible. Let's put it that way. Reliability and information on the web. I watched a thing on TV the other day, and I watch a lot of political shows. Politics has always fascinated me. I do lean more to the left, but I do watch some of the things on conservative talk shows also to kind of keep a balance. But I was watching a left show, more liberal show, and the guy who was in there was talking about Donald Trump. And he was mentioning how Trump, a lot of times when he talks about different things, talks about the National Enquirer. And then they had a quote where they actually had Trump on TV, and he said, well, most of the news I get on the internet. Well, it's kind of funny that people can sometimes equate the National Enquirer and the internet. And the reason for that is anyone who wants to can put out anything on the internet. I can go out there right now on the internet and find just some totally garbage stuff on some totally garbage topic. And, some people will look at that and think that it's all real. Just like some people will read things in the National Enquirer and think that they're all real. What that has to do with this slide, though, is any information that you find on the internet, all right, questions you want to ask are ones like these. Is the organization that's putting this out there credible? If you've never heard of it before and it's saying something that seems really out there, it could be fabricated. How recent is the information? Are there links to additional resources? Is it Wikipedia? And Wikipedia is sort of an online encyclopedia, yet it's not. And what I mean by that is anyone who basically registers can go out to Wikipedia and edit Wikipedia web pages. So a lot of people think that the information that's out there on a site like wikipedia.org isn't credible. Is not credible. All right? I say take it with a grain of salt. It's a good starting point. But just like with anything, you should never just take for granted just because something's out there on any kind of medium, whether it's in a newspaper, a magazine, online. You shouldn't just jump to the conclusion that it's credible. All right. So let's look. Go back to the book here. And we're at the checkpoint here. And I just want to go back and double check and make sure I'm not missing anything. All right, looks like it pretty much is okay. All right. Let's jump up to, it's page 8 in the book on the bottom of the page, the network overview. Now, this is not a class. Oops. Sorry. This is not a class in hardware. This is not a program that deals in hardware, but it's kind of nice if you have at least a fundamental understanding of what's being talked about here in regards to hardware. All right? So the first thing that's mentioned here is a computer network. And the idea behind a network is it's two or more computers that are connected together, either physically connected or connected by some other means. Typically, if the computers are physically connected, they're known as a local area network. All right, because usually, again, there's a physical connection. So the computers in your classroom are physically connected to one another. But, for example, with Rankin, there's the Wentzville campus, where I teach, and there's the St. Louis campus. All right? And the idea is, it wouldn't make much sense to physically run cables under the road or whatever for the 30 or however many miles there are between the two campuses. But yet, it may very well, there may very well be a need for those campuses to have computers that are connected to one another. So in that case, it's not a local area network, also known as a LAN. It's a wide area network, which is also known as a WAN. All right, the Internet backbone, a high-capacity communication link that carries data gathered from smaller links that interconnect with it. And if you look at this map, I think this is the one I want to show you. Most of the time when people take a look at a map of how all this stuff is interconnected, let's see. Well, the one I was looking for actually is, I don't see it, is, let's see in here if that's it. Well, what they're trying to show there is, in many ways, the world is a wide area network, because it is possible for you to send emails or do whatever where you are able to talk to anyone literally in the world. All right, I've got friends who live in other states that I communicate with on a fairly regular basis. My daughter, my oldest daughter, was involved in soccer, and for several years, she played in tournaments all over the United States. She also was fortunate enough to play in a tournament out in Denmark, and we communicated while she was out there on her tournament. etc. Now, they're going to talk here about the client-server model, and they're going to show this, but I just want to mention when you take a look at it, I'm going to back up in a second, but I do want you to see this, because what they show is a web client, and they show as a web server. I have no problem at all with what's in there, but there are two things I want to mention. The first thing is, more and more as time is going on, the web client is not a computer like this. It is a mobile device, meaning either it's an iPad or a some other kind of tablet, or it's a phone. So the client does not have to be, all right, the client does not have to be a full-fledged computer like you see right here. All right. The other thing is, you work with products, and you'll hear about these as we go on. One is called XAMPP or XAMPP. XAMPP, I think it is. It's either two M's or two P's in it. But what it is it allows you to use your own computer as both a client and as a server. All right? So client server, it's still used today, but it's more an antiquated term to describe the relationship between basically two computers. The client, which today we usually look at as being the browser when you talk client server, and the server, all right, that basically transmits the results. So in other words, let's suppose for a minute that you're at your home. And while you're at your home, you come out and you type in, I'm using an older computer here, so I can't have a lot of stuff open or it starts to really slow up. So I decide I'm going to come out to rankin.edu. So I go out there. All right. What happens when I sit there and I type in rankin.edu from my computer at my home and hit enter is literally, as they start to show right in here, my browser is going to make a request, and an even more specific terms, it makes what's called a hypertext transfer protocol, or an HTTP request. That request is going to go someplace to a server, which is either going to answer the request itself, or it's going to call another server to answer the request itself. And regardless, this server here will eventually send an HTTP, or a hypertext transfer protocol, response back to the client. So that's what they're talking about here. The client makes a request. The server does the best it can to fulfill the request. Again, the client usually is running a web browser. I'm going to recommend it in here that the web browser that you use virtually all the time be Google Chrome. All right? It's one of the latest. It's one of the greatest. It's one of the most popular, if not the most popular browser right now. And it tends to support everything that we want to do. If you decide, no, I want to use Firefox, or I want to use Safari, or I want to use Opera, or I even want to use IE, you should be able to use those all as long as you're using a current enough version. But the client, as it says, connects to the internet as needed. It runs the web browser. It uses what I already mentioned to you, HTTP, the Hypertext Transfer Protocol, to make HTTP requests to a web server, and it receives an HTTP response back from a web server. The server, notice the client connects to the internet on an as-needed basis. The server must always, 24/7, 365 days a year, is connected to the internet, because you never know when you want to buy something or whatever. The server runs web server software. There are two examples listed here. One is Apache, and the other one is Internet Information Server, which is IIS, which is, for lack of better words, it's kind of Microsoft's version of Apache. The web server also uses HTTP. Again, the web server receives HTTP requests from a browser, and it responds by sending back HTTP responses to the browser. As we go on in here, we'll work more with things like MIME types. MIME, as you can see, is an acronym here, Multi-Purpose Internet Mail Extension. And there are times you're going to have to let the computer know what kind of program or what kind of file or what kind of whatever you're working with. All right, I mentioned before HTTP, the Hypertext Transfer Protocol. HTTP is one of the internet protocols that are available to you. Notice here they define a protocol as being rules basically used for clients and servers to communicate over a network. There's no single protocol that makes the internet and the web work. There's a number of protocols. We already talked a little about HTTP. Let's talk about another one, FTP, which is an acronym that stands for File Transfer Protocol. Now, you may have used FTP in the past and not even realize it. If you've ever gone out to a site where you don't have to log in, but you can actually download information from a computer, if you've ever done that, you probably have logged in, what's referred to typically as you've logged in anonymously. All right? And now you're able to go in and download information. So downloading meaning it's coming from the server to you. If you have to log in and you need an account, etc., then you can also, typically, not only can you download, but you can upload, which means you're sending information from your computer to a server. But FTP is used a lot with websites. Typically, you use some kind of an FTP program because you've tested your website on your own machine, and now you want to go out and you want to send it out to some kind of an internet service provider or someplace where it can be used. All right, we'll much more on that as we go on. There are email protocols, SMTP, POP, POP3, IMAP, and there are other ones. All right, I don't know if it really pays in here to go into a lot of depth and breadth of coverage on it. Again, the information that I'm covering with you right now is about on page 11. All right, we've talked a little bit about HTTP. You can see there the HTTP request and the HTTP response. There's also TCP/IP, Transmission Control Protocol, Internet Protocol. As it says, it's been adopted as the official communication protocol of the Internet. All right, to try to make sure that communication works, and it works in a standard way, and it works in a reliable way. The TCP part, as it says there, its purpose is to ensure the integrity of communication. It breaks, you may or may not have ever heard the old saying that you can't shove 10 pounds worth into a 5-pound bag. Well, here, where it talks about breaking files and messages into individual packet units called packets, typically if you want to be able to send something over the internet, and if it's real huge, you can't send it all at once. So you break it up into pieces. All right, some people call that serializing it. Okay? And then when you put those packets and you send them across the internet and they get to their destination, they have to be put back together again, typically known as deserializing. So that's the TCP part. The IP part is the Internet Protocol. As it says, it's a set of rules that controls how data is sent between computers. Every single computer that you work with has a unique numeric IP address. All right? And what they're saying here, and I don't know if that's going to work or not, but we're going to try just for the heck of it here. I'm going to grab all that information that you see right there, and I'm going to go over here, and I'm going to paste that in, and I'm going to hit enter. Now, I don't know if that's going to actually get me to Google, or it might get me to eventually to an error message. But in English, what the book is saying right here is you and I are used to typing in google.com or www.google.com or maybe http://www.google.com or something along those lines. All right? Because it's much easier to type that in than it is to remember something like 74.125.225.78. That right there is an IP address. And what happens is there's software that's known as DNS or domain name service software that takes the google.com and it converts it into something that looks like this. In other words, as it says, it'll take the IP address and correspond it to some kind of a domain name. Okay? This is what I was just mentioning to you. Again, this is pretty heavy stuff. And if you say, geez, am I going to have to know all this kind of stuff? In order to create websites, no, but it's nice to know what's happening in the background. And when people have asked me that kind of question before, do I have to know this? Do I have to know that? I come back and say something along the lines of, as an example, me personally, I'm not real good with cars, but I know enough about a car. All right? Years ago, I took a trip out west with some friends, and I had seen the weekend before I went, 60 Minutes, this was many years ago, had a thing on about people who were basically coming in and trying to rip people off by saying, hey, you have a problem here, your shocks are leaking or whatever, okay? And I got hit by that. In other words, somebody came up and said, hey, you got a problem with this. But luckily for me, I had seen that on 60 Minutes, and I knew they were trying to take me. And I said, that's okay, I'll get it fixed. I'm not from around here, I'll get it fixed when I get home. Oh, no, that won't last till you get home. Well, I'll take the chance. All right? All right, with this domain name system, as it says, it's the domain name that you create. For instance, www.rankin.edu. All right? When you type that in, literally, so if you type in this, or if you type in, even if it's just rankin.edu, that has to be basically converted into something like this. In other words, the domain name system has got to associate what you keyed in there, that text-based domain name, with a unique computer IP address for a web server that's connected to Rankin. Now, when you look at the stuff that's in here, and this picture is shown in the book on page 13, notice a URI and a URL. Most people know what a URL is. You look at this and you go, well, look, that's a URL right there, which pretty much is the case. But a URL is part of what's called a URI. All right? So the URL is the Uniform Resource Locator. As it says, it's a type of URI. And a URL is made up of several different components. As you can see, you've got the protocol, which is the http:// You've got the web server computer name, all right, the www. You've got the domain name, which is, in this case, webdevbasics.net. Then underneath that, you've got a folder name, and underneath that, you've got the name of a web page. Now, I'm going to explain something. I'm going to put a little bit of stuff on the screen right here, just so you see this, because it's stuff that I think, at least, is important for you to at least start hearing and hopefully understanding. All right? So if I go in and literally type in just rankin.edu, then what happens is, by default, the system goes and it looks and it says, is there a file under rankin.edu that's called index.html? So it looks for that file first. Let's say it doesn't find it. Then it looks to see, is there a file called rankin.edu/index.htm? You may or may not remember this, depending on how many years you've been in computers, but years ago, what was called the file name extension, which is what comes after the period, you were limited to 3 letters. You're not, of course, anymore, but you used to be. That's why it looks for HTML first, then it looks for HTML. If it can't find those, then it comes in and it says, okay, do you have a file that's called default.html or default.htm? So that's what it's actually looking for first when it gets there. Then if it can't find the file after that, then it starts to go and look and see, well, do you have a file called index.php, or do you have one that's called index.aspx, or do you have one that's maybe called, oh, I don't know, for example, index.jsp, and there can be others. All right? What I want you to understand is when you type in this, it's the chances are it's going to bring up one of these files. All right? And the first 4 that you see right here, the ones that are right up above these equal signs that I'm putting in there. So those, everything that's in here, all right, these are what are known as static web pages. So if you've got a web page that ends with .html or .html or .htm rather, it's static, which means that typically it doesn't change much. Many years ago, what happened was you would have people who would literally have, for example, like one of the little trifold handout. Maybe you've seen those at different businesses. And the trifold handout, you know, you've basically an 8.5 by 11 piece of paper that was folded into thirds that could have a front and a back to it. So it had 6 different sections. And a lot of companies, that was their marketing. So a lot of those companies, when they were told, oh, you got to have a web presence, if they didn't have anyone who worked for them that knew anything about the web, then usually what they ended up doing was taking that trifold and putting it out on the web, and that became their website. It was just all the stuff that they had been putting out there in the trifold piece of paper. So anything that you have here that are static web pages means typically they're not going to change often. And the reason that they're not going to change often is because for them to change, literally the person who developed the web pages has to go in there and physically make a change. Typically that means taking the website down. You wouldn't want to do that. But that does not cut it today. Today we need what's referred to typically as dynamicity in our web pages, which means, for example, if I go out right now, and I haven't gone out here for a bit, but if I go out here, let's say I go out here right now, and I go to Amazon.com. All right. Well, it sees some stuff in here, and my daughter was on here. She uses my account sometimes, which might be why some of this stuff is here. But if I come out here, and as an example, if I go out to books, and I type in, for example, how to create a website. All right, it's going to give me a bunch of books, right? And let's assume for a second, this one right here, how to create a website, that's exactly what I want, let's just say. So I click that. And right now, there's nothing special about what's going on. There is some magic that happens soon, but what I want to show you is this. As soon as Amazon sees that you've done this, it says, oh, well, this guy hopefully is, or this gal is hopefully going to buy something from here. Let's make some more suggestions to them of other things they might want to buy. That's the dynamicity part. All right? Maybe you've gone out to a website before, and there are ones out there like this, that they ask you your favorite color, or your favorite this, or your favorite that. And you tell them that, and maybe they make the website that color. All right, that kind of an idea. All right. A top-level domain name, as it says, it identifies the rightmost part of a domain name. Now, you can see some of them in there. For instance, if I were, instead of typing in rankin.edu, I typed in rankin.com, then the system would be expecting that it would be bringing up some kind of an e-commerce or commercial site. All right? EDU sites are for education. MIO for military, GOV for government, etc. There's a lot of them that are fairly new that are in here. It used to be there was like com, org, net, maybe pretty much everything on the first line here. Maybe not arrow, but everything. These 1, 2, 3, 4, 5, 6. Com, org, net, mil, gov, and edu. That handled just about everything. Today, too, quite often you actually include country codes. All right, as it says, 2-character codes originally intended to indicate the geographical location or country of the website. Now here's a little bit more on that. Okay, and again, if you do take a look, this is on page 15 of the book. They talk some more about this domain name system. And they say that, again, it associates domain names with IP addresses. And the following happens each time a new URL is put into the address bar in the web browser. First, the domain name system, or DNS, is accessed. Second, the corresponding IP address is obtained and returned to the web browser. Third, the web browser sends a hypertext transfer protocol request to the destination computer with the corresponding IP address. Fourth, the hypertext transfer protocol request is received by the web server. Fifth, the necessary files are located by the web server and sent via a hypertext transfer protocol response to the web browser. And sixth, the web browser then renders and displays the web page and any associated files. Again, that's on page 15 of the book, and that's pretty much what the author is trying to show right here. All right, markup languages. In the beginning, before there was HTML, there was something called SGML, the standard generalized markup language. And as it says, it was a standard for specifying a markup language. But it was done in such a general way, hence the name here, that it was never really used. It was meant to be used more as a template that other languages could use. From there, HTML was born. As it says, there's all sorts of debate that people have as to whether HTML is actually a programming language or not. Some people say it is, other people say no, it's a markup language, and that's what the ML stands for. But as it says, it's a set of symbols or codes placed in a file intended to be displayed on a web browser. Well, HTML was doing its thing, and you had HTML 1 and 2 and 3 and 4 and 4.01 and 4.1. And people were saying this was maybe in the 90s or so. I don't know exactly when, maybe in the early 2000s. I don't remember. But people were saying HTML isn't really cutting it anymore. So they started to come up with a new language that's called XML, the Extensible Markup Language. And the big difference between HTML and XML is HTML, at the time at least, had about 70, 80, maybe 90 tags that meant a specific thing. It could only be used in a certain way. All right? And XML, you made your own tags. Now, the author says here it is not intended to replace HTML. Well, originally, it was designed pretty much to replace HTML, but it didn't happen. Many people found using XML kind of boxy and kind of hard to use. So a decision was made that, well we're not going to go right from HTML to XML. Let's have this thing in between that's called XHTML, which is ideally going to combine the best of all worlds. All right? And that was never really quite as popular or whatever either as people thought it would be. So what had happened was in the early 2000s sometime, I can't tell you exactly when this was. You can look it up online. The people from the W3C and other people, other organizations, one is Watt MG or something like that, they all started saying, you know what, maybe we should go back again to HTML and make a new version and have it do some of the things we always wanted HTML to do, but that it didn't do. And that's kind of how HTML5 was born. All right, I'm giving you kind of a watered down story of it, but that's pretty much what happened. So I don't think that there's much in here we have to really mention. The internet is popular for just about anything. All right. You know, you've heard how that in some places at least, some companies will tell you that their internet presence is much more important than their brick and mortar presence. So in other words, I can't tell you whether or not, for example, Barnes & Noble sells more books in its stores or online. But I bet you it's pretty darn even between the two. In fact, probably they sell more online, to be honest with you. So this chapter, as mentioned here, was designed to be just a brief overview of the internet, the World Wide Web, and some introductory networking concepts. Well, that's it for this first chapter. And when I go on and come back with the next lecture, we'll go into Chapter 2. In Chapter 2, which starts in the textbook on page 25, is entitled HTML Basics. So what we'll do is a combination again of looking at the PowerPoint slides, and I'll write some very simple HTML for you also. Okay? Hopefully you find what I'm going over in this book to be helpful. If you do, feel free to let me know. If you don't, feel free to let me know. All right? Thanks a lot.